Okay, 1 o'clock? Cool. So everyone, standard normal distribution. We're going to be learning about normal distribution. So the key concept we want to learn for today's class is the standard normal distribution, its properties, that the graph is a bell-shaped curve, that the mean is 0, so we say mu equals to 0. The standard deviation is equal to 1, and the standard deviation is sigma. And also we want to figure out how to find these values, what a z-score is, and how it corresponds to probability. So if you remember in your previous homework, you were given something that looks like this, a frequency table with the weights, and then you were asked to plot a histogram. So with each different weight, you were asked to give it how many. This follows a normal distribution. It increases and then decreases, so that's a bell-shaped curve. And a normal distribution is just the ideal case of something like this. So that is where it comes from for your previous, you've seen it before. A density curve is a graph of continuous probability distribution. So if you look at before, it is not continuous. It's discrete, right? There's one value for each thing. Normal distribution is the ideal case, so it's continuous. It doesn't end. The entire area under a normal curve is the same as the entire probability, right? If you were to add up all of these frequencies, that would be the entire frequency, and that would be what's underneath when you divide by what's the probability I'm going to find a weight between these two. Well, it's going to be 3 over the sum of this. So you can think of that as total probability. It's very important that you remember the entire area under a normal curve is equal to 1. That every point on the curve must be greater than 0. So you can't have a negative value in your normal distribution. So area and probability is the same thing. This right here is a standard normal distribution. And the x-axis right here, the x-ticks, is what we call a z-score. It's kind of like a normalized score. So the mean is going to be 0, and the standard deviation is 1. So here, tick is 1 standard deviation away from the mean, 2, 3, and so on. And it generally looks like this. We can use different technologies, different ways to figure out what is that area under the curve given a z-score. You've probably seen your homework or your book reference this chart, table A2. I'm going to ask you to just ignore the chart, and I will show you how to use it in Excel because it's easier and less mistakes are made. If you do want to learn how to use the chart, please come by my office hours. I'll be more than happy to show you. So using Excel, these two functions are your friend. Norm.dis, that stands for normal distribution. And you want to input 3 things, x being x value, so whatever value you're trying to find that's related to the probability, your mean. And in this case, since we're using a standard normal distribution, our mean is going to be 0 and our standard deviation is going to be 1. So that's the same as using norm.s.dis. This s stands for standard. So you're entering in a z-score for x and a mean of 0 and a standard deviation of 1. So let me demonstrate using actual Excel. Say I just type in norm, and you can already see I have a few options to pick. So which one do you want to do, norm dist or norm s dist? S. Okay, cool. So say I want to find a z-score for something, 1.25. What is the probability I will have a z-score less than 1.25? That's a 98% probability. What that looks like when you're putting it in, how you should visualize it, is if I wanted to find probability of z is less than 1.2, okay, it was 1.27. 1.27 is my example. I'm finding the area to the left of 1.27. Excel doesn't ask you whether you're shading to the right or shading to the left. It just always assumes that you're asking for the probability that is less than whatever value you're putting in. So Excel always automatically just assumes you're shading to the left. So just keep that in mind when you're entering in your numbers. Make sure you understand if you're looking for a value that z is less than or a value that z is greater than, because that will impact what your answer is going to be. So let's hit it off with an example. is our real life example. You're all gonna be doctors. The result of the test is commonly measured as a z-score, which is a normal distribution of a mean of 0 and a standard deviation of 1. So that's just, all this is just noise saying, we're gonna use a standard normal distribution here. Find a probability that the result is, in a reading, is less than 1.27. So that's just saying, if I had, assuming like a population, just pick someone off the street, give them a bone mineral density test with or without their consent, that the score is gonna pop out 1.27. And we're going to assume, alright, sorry, the formatting was weird. I use Linux and this is Windows, so. I just highlighted less than to let you know that this is, to let you know less than is a very important keyword, what you're looking for. So this is the probability, 0.898. So you can imagine that about 89.8% of the population will have a bone density test that's less than 1.27. So that's just how you interpret these numbers into real life data. And this is the same thing. Second example, using the same bone density test, find a probability that a randomly selected person has a result above -1. So what does above translate to? Yeah, shade to the right, more than. So whatever you put into Excel, you're going to have to subtract by 1. So what I do in Excel is the same function, norm sdist, and I put in that value, -1. What they're going to give me is the probability that someone is less than. And since we know that the probability someone is less than plus the probability someone's greater than is adding to 1, right? The entire curve under normal distribution is 1. We can subtract our answer by 1 to find out what the shaded area to the right is going to be. So this is what it looks like visually. I suggest with these problems, when you attack them, to first draw out what the normal distribution is. First draw a line indicating where you think that z-tick is going to be, and then shade to the right or left depending on the question. So just you know what it looks like when they're trying to ask you. So what about between? How are you going to do that? Well, it's a little bit of algebra. What you have to do is you have to find area A that's shaded to the left, and then you find area B that's shaded all the way to the left. So B includes A. But what you want is just the area in between, so you subtract out A. How that looks like with actual example is if I were to give a bone density reading between -1 and -2.5. Well, I already have -1, we found that in Excel. The area to the left of -1 is about 15%. So now let me find the area to the left of -2.5. Norm dot disk -2.5. Okay, now I need to subtract the two values. What if I make, why is this not going to give me the correct answer if I subtract it this way? If I subtract this one from this one, why is the answer -0.152 not really possible? You can't get a negative probability. Yes, probability has to be a number between 0 and 1. So if you're doing your equation, you're about to type in your answer, double check. Make sure that what you're typing in is a probability that makes sense. So what I want to do is opposite of that, large minus small, enter. So if you're a little confused as to which number do I subtract from the other one, big minus small. You want a positive number. So I get the same number but just positive, 15%. Right here. Yay, answer. That's what it looks like visually. So some notation, just so you know, you've probably seen this before when we were learning about probabilities. Between A and B, Z is greater than A, so that is when you need to shade to the right, because the positive numbers gets greater. If you go to the right, it gets less as you go to the left. Just follow where the arrow points. So finding z-scores when given probabilities. This is the opposite of what we've been doing, right? We've been associating a z-score with a probability. Now we're going to do the opposite. We're given a probability, and we want to find what z-score is associated with. So we want to do the inverse using norm dot inverse. Cool, easy to remember. These two be your best friends for like now to the next end of the semester. We are given the example, find the 95th percentile. So that's just another way of saying find the area to the left of 95%. So what I want to use is norm dot s dot inverse. And I put in 0.95. Excel assumes I'm shading to the left, so it'll give me a positive z-score. Now, this is 95th percentile. What about the 5th percentile? Is that going to be the same? Anyone want to predict something? Yes, no, maybe so.
Is the negative?
It'll be the negative version of it.
Woohoo!
The reason behind this is that the normal distribution is symmetric. Whatever's on the right is on the left. So if you find a 95th percentile, you know that this little empty space is about 5%. And so at the exact opposite of it, at the 5th percentile, it's going to be the same z value, just negative. And there's the answer. So using the same bone density test, find a bone density score that separates the bottom 2.5% from the top 2.5%. So which one do you want to find? Which number do you want to enter into norm.s.inverse that gives, say, the least amount of work? Just do it once. We'll give you the right number. 0.025. Great. And what would be, so we want two values, right? So we got negative 1.95, well, negative 1.96. What would the second value be? Positive 1.96. So you don't even need to enter it into Excel again. But if you don't believe me, I'll do it anyways. So you don't have to. Oops. It'll be 1 minus. I got it. Don't make the same mistake I did. 1 minus. There you go. So you can also think that with positive z-scores, larger area. What is a critical value? Well, that's what we've been finding is a critical value. It's the score that separates the values from what is likely to occur. So if you remember in your homework, we have things like what is unusual, what 0.05% or whatnot, if that looks familiar, that's our alpha. So we want to find a z-score that's associated with that probability, and that's what we call a critical value. So the expression z of a denotes a z-score with the area a to the right. So for example, if we wanted to find z of 0.025, how will we do that? Well, which function will we be using in Excel? We'll be using norm.inverse. Because this 0.025 is a probability, right? And what we want to find is a z-value. So if you remember back to this graphic, we are given a probability, usually it's called alpha, and we want to find the z-value. It's usually called a critical value. And putting in 1.25, we should get the same thing that we got before. 0.025. So the reason why this 0.025 comes up a lot is we statisticians use alpha equals 0.5 a lot. And sometimes we use a thing called a two-tailed test, which we split up alpha into two equal mirror images, so we need to divide it by 5. And 0.025 divided by 5 is 0.05 divided in half is 0.025. All right, so we have about 5 minutes of extra time, and let's do some practice problems.
You were DL2, D2.
Desire learning too.
I have dyslexia. Pearson and, loading up some practice problems from my stat lab that we can do together, so you won't be confused when you're sitting around in the mile.
Thank you.
And this is Pearson login, and this is my lessons plan, and these are our if time activities. So, find the area of the shaded region. The graph to the right depicts a standard normal distribution with a mean of 0 and a standard deviation of 1. And in case no one can see this because I'm awful at screenshots, the z is equal to 0.75. So how would you do this? What Excel function would you be using? You got two options. Norm.s.dist, awesome. And what would I be putting in as my z-score?
The one is given.
75. Okay, is this a probability? Because it's less than 1, right? Like, is this 75%? Is this a probability? No, it's not. It's a z-score. Probability is area. That's what we're finding. The z-score is given here. So if mean is 0, then 0.75 is just barely to the right of it. So we should expect a value that's very close to 50%, right? Okay, that's not very close, but not 80%. 75. All right. Assume a randomly selected person is given this bone density test. Test scores are normally distributed, same thing. Find a probability if that given score is less than negative 1.89 by first drawing a sketch of the region, then using Excel function norm.dis. So I'm going to use chalk. What I want you to do when you do these homeworks is to draw a normal distribution. All right. So I know that in the middle is going to be 0. And where do I want to put this z-score? It's going to be
To the right.
right here. Yep.
Oh.
Negative 1.89. And so am I going to be shading to the right or to the left? It's going to be less than. So I'm going to be shading to the left. And Excel automatically shades to the left, so I don't need to change anything when I enter that in. Got this, so I'm just going to change this value to negative 1.89. And there we go, that's the answer. Copy it down, put that in stat lab later. They randomly generate it, so can't actually do that. Sorry. I'm trying to get you to cheat. Next question, number 3, same deal, but we're looking for a score that is greater than, holy crap, I see why chalk is phased out. Greater than 1.73. So here is 1.73, and we want a greater than, so we're shading to the right. That's what it looks like. So what do we need to change when we put in our Excel function? All right, so do I do 1 minus 73 inside the perimeter? Oh shoot, what happened? Do I do 1.73 inside the parentheses? No, you don't want to do that. That's moving your x. The reason why we do 1 minus is because we're changing the area. So you got to do 1 minus outside of the parentheses after you're given the area. You can do it like this, or if you're super clever, you can remember that the standard normal distribution is symmetric. So if I'm given positive 1.93 and I want to find the area associated with it, I can just enter the negative value and I should get the exact same answer, 1.73. There you go, math magic.
Yay. Sweet.
So that'll be all for